नमस्ते सबैजनालाई आजको यस एपिसोडमा यहाँलाई स्वागत छ. Today we have a very special guest, Richard Brown, who is a ex-president of Amateur Astronomical Society of Newcastle and a PhD in psychology. Welcome to the podcast, Richard.
Namaste, Sula. Thank you for having me.
No worries. How have you been these days, Richard?
Very good. Very good. Very busy at work, but also very busy outside following my hobby, which is astronomy.
That's right. And I understand, Richard, you have been engaged in this hobby for the last 50 years.
That's correct.
So tell us about that interesting experience you had.
As a small child, my parents realised I was interested in looking at the sky, so they bought me a very small telescope.
Yeah.
And it's taken off from there. So that was 1967.
Wow.
And now in 2025, I'm still getting outside and looking up and still enjoying the sights of the heavens. You can go outside anytime you want and look up at the stars and the moon and the planets and just enjoy them for their own sake. Or you can get telescopes and binoculars and look at them. There are apps available on your phone that help you look around the sky.
Yeah.
And in fact, if you point to a part of the sky, the app will tell you what you're looking at and explain all the stars and planets and things that are there.
Yeah.
It's a fabulous development. I've gone a little bit more into astronomy in recent decades, I suppose, and contributed to what's called citizen science.
Yeah.
So as an amateur in my backyard, I can actually contribute valid and important scientific information to astronomers worldwide so they can understand what's going on in the universe.
Wow.
I spent many, many years looking for comets and reporting observations of known comets to observatories around the world.
Yeah.
But lately, in the last few years, I've started to contribute to the measurement of asteroids. And asteroids are those big chunks of rock that could be 100 metres wide, could be 100 kilometres wide, that orbit around the sun like the planets. And every now and then, one of those big pieces of rock goes in front of a star and it blinks its light out. And then when it moves on, the star comes back on.
Wow.
If you measure the time from the moment the star blinks out to the moment the star blinks back on again, which is only can be a couple of seconds at times.
Sure.
Some very clever people can then work out the size of the asteroid down to a very, very accurate size. And that's very important information for astronomers who are still trying to work out the construction and structure of our local solar system.
Wow.
All those planets and asteroids that orbit around the sun, including the Earth.
Yeah.
Still trying to understand what's happening out there, and probably be for decades to come, collecting information to try and understand what's going on even in our local area, let alone the rest of the universe. Wow. So that's what I'm doing.
Wow, wow. I mean, that is a very interesting project that you have been, recently working on. And we would like to wish you all the best. Hopefully hopefully you'll be able to, discover some really interesting fact and contribute towards the Astronomical Society for sure, isn't it?
Yes.
Yeah. And while you're mentioning about the telescope and binoculars, we probably will, later down this episode, we probably will discuss about what is the starting point for someone who really wants to, do the night sky. We'll discuss about the, entry point of those equipments as well. And also later down this episode, we'll probably share our screen and see what is the best software to have a look at all these celestial objects and stuff like that.
Yes.
Yeah. So being myself from Nepal, we have a different view of the sky than what we see from Australia. We have constellation like Big Dipper. We call in Nepalese, Saptarishi. The audience who are looking this episode, they would recognize straight away what Saptarishi is, But quite interestingly, not everyone may have looked at the night sky and tried to figure out what stars actually form this constellation,
Yes.
So and we will definitely show this sort of thing by sharing our screen later on. So what causes this view of the sky from the northern hemisphere to southern hemisphere, Richard?
It's to do with the curve of the Earth.
Yeah.
And if you're in Nepal, you can see the Big Dipper and the pole star Polaris and the Big Dipper rotating around it.
Yeah.
In the south of the equator, if you come around the Earth, we can't see it.
That's right.
But we can see a different part of the sky that people in Nepal can't see. And that's the southern sky. So depending where you are on the Earth, north or south of the equator, it will determine what you can see in the sky.
Right.
So In Nepal, you have a view to the north
Yeah.
that gives you the Big Dipper and other things. Excuse me. In the south, we've got a different view because we're south of the equator and therefore looking at a different part of the sky that Nepal can't see.
Yeah, absolutely. And when you just touch base on Polaris, I mean, Polaris is a very prominent star in northern hemisphere.
Yes.
Of course, it's a northern star, and then we call it Dhruvatara.
Right.
Audience will recognize this name as well, And so, like Polaris, do we have any sort of prominent star that will be helpful to determine the direction and stuff like that? Back in like 100 years ago, when sailors used to determine the direction and stuff like that.
We have a southern pole star.
Yeah.
But it's so faint you need a telescope to see it.
Right. Okay.
So it's no good.
Yeah.
In terms of going out and looking and go, there's the south pole star.
Yep.
It's like the opposite of Polaris.
Right.
Except it's very, very faint.
Right.
And it's below most people's ability to see.
Right.
Given that, you can use tricks to find the south.
Yep.
Particularly with the Southern Cross, which is a very famous constellation.
Yep.
And a very bright constellation that people in the Southern Hemisphere can see.
Right.
You can use the Southern Cross to point south at any time of the day.
Yeah. Thank you very much, Richard, for that beautiful insight. So in Nepal, most of our festivals, they are aligned on the lunar calendar.
Yes.
Many festivals, especially there is a very upcoming festival which is Deepavali, Tihar we call it. It happens to occur in new moon. New moon is in a couple of days, and then most of our festivals are either in a full moon and in a new moon because we are based on the lunar calendar. But I think Western world is more on a solar calendar, isn't it?
Well, it is, but there are some very important Western Christian festivals that are based on the moon, and that's Easter.
Oh, okay.
Easter is based on where the full moon occurs after what's called the equinox, when the sun travels north or south of the equator.
Yeah.
So that yes, there are some lunar-based holidays and festivals, but not as many as we would find on the Nepalese holiday calendar.
Right. Thank you very much, Richard, for that insight. Now let's move on to some of the brightest stars that we can see in Nepal and that we can see in Australia. So I'll begin with the brightest star that we can see from Nepal. So we can see Sirius.
Yes.
We can see Sirius from Southern Hemisphere as well, isn't
You
it?
certainly can. And in fact, where we are in Australia, Sirius is very much overhead.
Yeah.
Whereas in Nepal, Sirius tends to be south.
That's right.
And not overhead.
Yeah.
Because again, the curve of the Earth, we're looking up at Sirius.
Yeah.
Whereas in Nepal, you guys are looking further down, further south. So yes, there's a difference in the height or the angle of Sirius between the two countries.
That's right. And then the other interesting star that we can see in here and back in Nepal is Aldebaran in the constellation Taurus.
Yes, a very big red giant star.
Yeah.
Very prominent. And you can see it again in Nepal, that would be very close to overhead. But to us, it's north.
North, that's right.
And it never comes south. We never look up at Aldebaran. We look that way
at Aldebaran.
Right. Whereas in Nepal, you look up.
Yeah, exactly. Yeah, that's the difference that I noticed as well.
Yes.
And Arcturus.
Yes.
Arcturus, it's in Booth's constellation.
It is.
You see it very north, far north here, isn't it? But back home, it just top of your head.
Sits up, yes. Yeah. And again, it's just a testimony to the curvature of the Earth and where you happen to be.
Yeah.
When you're looking at the stars.
Yeah, absolutely. And then the other, let's move on to the stars that we can see only in Australia. I think Canopus, Alpha Centauri, Beta Centauri, Acrox.
Yes.
That's from the
These are very southern stars. Canopus is the second brightest star in the sky.
Right.
And when Sirius rises, you can see Canopus as well, but it's further south. And those two stars from Australia are in the sky together, and they're very bright and very similar colour.
Right.
So that they're like two little diamonds. Yeah. And when they come up, here in Australia, it's summertime.
That's right. Okay. So,
So-
in the constellation Orion, there is a very interesting star called Betelgeuse, and it is very orangey. Why it is orange, Richard?
It's known now that stars go through a life cycle of using nuclear power to burn or to change the state of the atoms in the star that gives it the energy and the heat and the light.
Yeah.
Betelgeuse has gone through a lot of energy,
Right.
and it's starting to get very, very old.
Yeah.
And as it changes the way it's looking for that energy, it starts to get big and red and expand and expand and expand to become a red giant.
Right.
And I'll tell you something, if you get on a jet and you fly around the Earth at normal jet speed, it'll take you about 24 hours.
Right.
So go right around the equator of the Earth,
Yeah.
24 hours. So you start in Kuala Lumpur, fly around, come back to Kuala Lumpur on a, Air Malaysia jet, 24 hours. To fly around the sun will take you 6 months.
Wow.
To fly around Betelgeuse will take you 700 years. That's how big it is.
Wow.
So it started out smaller, but because it's changing its chemical nature, because all the energy it's using to burn and, glow brightly, it's expanding. And that expansion goes on and on to the point where it then collapses.
How fascinating.
And becomes a supernova.
Wow.
Blows up.
Wow. So it will eventually become a supernova, isn't it?
That star's a very high chance it will.
Wow.
Yes.
Probably will.
Billions of years yet.
Yeah, exactly.
So we don't have to worry about it.
Yeah, absolutely.
But yes.
Yeah, but whoever will, witness that time, that would be spectacular to see. Probably.
It might be too spectacular.
Yeah, exactly. Right. So the other very interesting stuff that everyone puts up in their social media and stuff is aurora. So
yes,
how this aurora is formed, Richard, and the aurora, it can be only seen from a particular place, not from everywhere, isn't it?
Yes, that's right. It's an interaction of the Earth's magnetic field and matter that the sun is spitting out. And you may have seen films of the sun where it's sped up and you can see all these almost like flames. They're not flames, but red hot and white hot gas and what they call plasma being thrown off the sun. That material goes out into space, and within a few days it comes into contact with the Earth.
Right.
And when it comes into contact with the Earth's magnetic field, it changes the nature of gas in that magnetic field, oxygen and nitrogen and other gases, and they glow.
Yeah.
And when there's a lot of this material ejected from the sun in a solar storm, we see our magnetic field interacting with that matter, and it makes the sky glow, and that's the aurora.
That's right.
Also, you will get in these storms when the sun's thrown out a lot of this matter, interference with electronics, and satellites can be damaged and power lines can be affected.
Wow.
So that there was a very, very famous solar storm that threw out a lot of this matter, headed towards Earth. And in the old days, this is 150 years ago, when the men would operate the telegraph, the did-it, da-da-da-da-da to send telegraphs, a lot of them were killed because the magnetic change and the change in the electrical field of the Earth caused all the power lines or the telegraph lines to become electrified, and it shocked them and killed them.
Wow.
So that's how powerful that can be. But normally we see it as a fairly harmless but beautiful display. Now, because magnets work on a north and south pole with a magnetic field, if you've ever been at school and got some iron filings and put a magnet down, it forms a flow like this.
That's right.
That's what the Earth is. So the most concentrated magnetic fields are north and south, which is why you see the glow, because there's more magnetism up there, literally combining with the matter that's been ejected from the sun. So you only see it north and south. If it's a really bad storm, a lot of stuff, you can see it further and further towards the equator. Sometimes you can see it here in Australia at 33 degrees south, and sometimes you certainly see it in Nepal. But that's not as common as north or south, say at the North Pole or South Pole.
That's right. Yes. So people, we have seen people putting these pictures in their social media.
Yes, beautiful.
Especially up in Europe. And especially in Tasmania. I think they see a beautiful aurora there.
And each colour represents ions of a gas. In other words, green. I'm guessing green. I think represents oxygen.
Right.
And pink represents nitrogen.
Yeah.
Or the other way around. But it shows different gases being made to glow because of all this matter that's coming from the sun that's got a lot of energy in it.
Right. Wow. That is very fascinating, Richard, isn't it? I mean, as much interesting and beautiful as it seems, it has a lot of scientific implication behind it, isn't it?
And it's very powerful and can be, when there's a lot of it with a big storm, very dangerous.
Yeah.
Yeah.
Thank you very much for that explanation, Richard. And then moving on, we call it in Nepal, we call it Tara Mandal, and in English, of course, it's called star cluster. So where do we start to know more about the star clusters? Can this be seen using your basic binocular, or you need to have a telescope to see star clusters and stuff?
There are quite a few star clusters you can see without a telescope.
Oh, is it?
Just
Okay.
go look at them.
Yeah.
Near Aldebaran, the star in Taurus, there's a star cluster called the Pleiades, the Seven Sisters. It's a little compact group of stars.
Yeah.
It almost looks like the Big Dipper.
Oh, okay.
And it's not far away from Aldebaran. So if you can see Taurus,
Yeah.
if you look around, you'll see that cluster. Now, through binoculars, there's about 20 or 30 stars that you can see easily, all in a little group.
Yeah.
In the southern sky, which you can't see so much in Nepal, there are clusters of stars, what are called open clusters, everywhere.
Oh.
And that's what the southern sky is famous for, clusters of stars in the Milky Way.
Yeah.
So they're not hard to see. You can, with a pair of binoculars, see hundreds of clusters all over the sky.
Yeah.
And certainly from Nepal, you can see many, many clusters. Again, with your phone and an app and knowing where the clusters are, you point to a certain part of the sky, you see a cluster. Use your binoculars and there it'll be.
That's right.
So yes, very pretty.
Yep.
And on good nights when the seeing in the sky is very clear and still, you'll be able to make out different colours in the stars. And in fact, there's one cluster near the Southern Cross, very close to the Southern Cross. It's a very small looking cluster of stars that's called the jewel box because the stars in that cluster are red, blue, green, white and yellow. And they're absolutely beautiful.
Wow.
Yeah. So yes, the clusters are very, very interesting and pretty things to see. With a pair of binoculars, you'll see lots of them.
Wow. And thank you for that great explanation of that, Richard. And also, just to touch on that point, we have heard this celestial term called nebula. And then,
Yes.
And I think probably a few years ago, James Webb Telescope from NASA. James Webb Telescope released this image called "Form of Life." And then I think it was a nebula, and they were saying, that's where the star is formed. Is that right, Richard?
That, in some nebulae, yes.
Okay.
So what's happening is that great clouds of gas, literally clouds of gas and dust at times, pull in on their own gravity. And we think dust doesn't have much gravity or gas doesn't have much gravity about it, but it does. And eventually the dust and particularly the gas forms a very, very tight connection with itself.
Yeah.
And it becomes round.
Yeah.
And then it collapses in on itself. And this is on a very big scale. And all of a sudden there's enough mass in there and enough pressure to cause a nuclear reaction.
That's right.
And a star's born.
That's right.
So it's pure and simple gravity causing gas and dust to come together, reaching a point of such high pressure that the atoms are now pushed into a nuclear reaction, and the energy comes on, and the stars turn on.
Wow. And basically that's how we are formed.
Pretty well. And in fact, in stars, a lot of stars started out with just hydrogen.
Yeah.
And through the nuclear fusion process, what's happening is that heavier and heavier and heavier elements are being formed.
Yeah.
So that all the gold, for instance, in the Earth that you find has been formed in the few moments when a star has collapsed in on itself and blown up as a supernova.
Yeah.
In those moments, there's enough energy and pressure and whatever's needed to convert metals into gold.
Yeah.
And it explodes and forms gas and dust.
Wow.
So when the planets condense from dust clouds, from exploded stars before, which have happened before, that's why we get gold and other elements. They are literally the dust of exploded stars in the past.
Wow, that is very fascinating, isn't it, Richard? And when you just touched base on galaxies, we understand that there are like millions of galaxies, if not more, trillions of galaxies.
Trillions.
Exactly. And recently, astrophysicists are mentioning about this multiverse as well. So is this universe expanding in a rapid way, so that there is not only universe, but there is multiple of universe?
I don't know in my backyard, but some years back, an American living in Australia, now an Australian citizen, Professor Brian Schmidt, won the Nobel Prize in Physics for determining that the universe is actually not only growing in size, but accelerating.
That's right.
And that's a whole new understanding, or a whole new puzzle for astronomers and physicists to work out what's causing that acceleration.
Wow.
And what that answer is and what that depends on is still much a part of debate and research. Whether or not there are multi-universes is more a theoretical question at the moment that mathematicians and physicists argue about and have been arguing about for a very long time. What the true answer is not known, but quantum computing may suggest, or some people suggest, that the incredible instantaneous speed of calculation in quantum computing, which will make it such a revolution, may well be because in some ways the processing is being outsourced to other universes, taking billions and trillions of years to do and then coming straight back. Because of the weird nature of quantum states of being, which I really only know at the documentary TV level. But some people are thinking that there are multiple universes.
That is really great information about a multiverse and nebula and stuff. Thank you very much, Richard. And now I understand that you have been studying about moon for a long time, and you have the expertise of, especially the moon. And I have seen a couple of your fantastic photos taken from your, of course, telescope, that you managed to take such a crisp images of the moon. We'll probably see that later in this episode. But could you please tell us something about moon, how it is formed? And also there's a very interesting saying in Nepal that, it says even moon has its little marks, that's what in Nepal, that's a very famous saying. So what are those marks? And I understand there are craters and stuff. There has been some sort of volcanic episodes that might have gone millions of years ago and stuff. Would you be able to give some highlight on that, please, Richard?
Sure. It was thought at one stage that the moon somehow was birthed from the Earth, by the influence of a passing planet or body. But it appears now that there's been some sort of collision, although this is still up for argument. Some sort of collision has occurred, and the moon has consolidated from the debris of the collision with the Earth and that other body. And why is it so round? Well, if you think about it, if one piece of rock gets near another piece of rock, gets near another piece of rock, the gravitational attraction is from all directions going to the centre. So a bunch of rubble and rocks together will eventually become spherical. Just by the nature of their own gravity that's generated by the number of and the mass of the rocks coming together. So things become round as the nature of gravity.
That's right.
So we've got a round moon formed possibly from debris of a collision billions of years ago. And not only that, but in the early parts of the solar system, there was a lot of debris floating around. So this notion of a great bombardment of planets, particularly planets close to the sun like the Earth and the moon, with rubbish from the formation of the solar system. So there was a lot of meteorites hitting the Earth, and we can see evidence of that. Although it's weathered down because we have weather and rain and wind that wears these things down, and tectonic movement of the great plates of the continents on Earth. On the moon, there's no tectonic movement, there's no atmosphere, there's no weather to speak of. So a crater that can hit 1 billion years ago can still be seen.
That's right.
And if you have a look at the craters, which are generally formed by the impact of a rock, an asteroid, or a small piece of debris hitting the moon, they will gouge out a crater. And another rock 1 billion years later can hit near it and gouge out another crater. And so you can see how some craters are at the bottom of a whole series of other rocks hitting, meteorites hitting. And you can work out not only who's hit who first,
Yeah.
but the age can also be seen of these craters. And some of the craters on the moon are billions of years old
Wow.
and just sitting there because there's nothing to wear them out.
Yeah.
Whereas on the Earth, things get washed away and blown away pretty quick.
That's right.
So the imperfections on the moon that you see
Mm-hmm.
are not only larger craters, because you can't see the smaller ones without a telescope, but as you mentioned, there's a lot of volcanic activity on the moon
Yeah.
where a volcano would erupt or a great fissure would occur in the moon and lava would flow out.
That's right.
And great smooth areas that they call seas, by the way.
Yeah, okay.
The Latin is mare,
Oh, yeah.
as in maritime.
Right.
They call them seas. They're not seas,
Yeah.
but they're just great plains of lava.
Yeah.
And over time, they have themselves got meteor craters on them.
Wow.
And the newer or the more recent the lava flow, the less craters it's got on it.
Yeah. Wow.
And you can start to tell how old something is merely by the number of craters falling. So that's why the moon looks patchy and odd.
Yeah.
There's volcanic activity
Yep.
forming great masses of lava,
Yep.
and which is quite dark.
Yep.
And there are meteors hitting it or have hit it in the billions of years that have gone by, causing it to look like an absolute mess in some parts of its surface,
Right.
which makes it quite fascinating to look at through a telescope.
Yeah, absolutely.
Or take photographs. And I've spent many, many years trying to take the perfect photo, which you never will
That's right.
from Earth.
Yeah.
But you keep trying.
You keep trying, exactly, especially in the really, nice clean sky, especially
Yes.
in the full, new moon probably, isn't it, Richard?
Yes. You need the best place to take a photo of the moon is on what they call the terminator. So
Yeah.
if you see the moon as half, along that shadow line,
Yeah.
all the shadows are long, like here in the morning or the evening, the shadows get long because the sun's either rising or setting on that line,
Yeah.
which they call the terminator. There is the best place to take close-up photos because you've got all the contrast of the long shadows.
That's right.
And you can see the long shadows of mountains and meteor craters, and it looks fantastic. So that's the best place to take a photograph, where the light becomes shadow on the moon.
Wow.
A full moon
Yeah.
is no good for photographing.
Absolutely.
It's too much light,
Too much.
everything looks flat.
Yep.
You've got to get the crescent
Yep.
or the edge, the terminator of the moon, to see where the most detail is.
Wow. And you mentioned about these craters, and then we often hear about this times Tycho crater. And one day, I think I have seen it from my binocular as well. When I was
Yes.
looking through my binocular, I had seen that Tycho crater as well. Is that a very prominent and very famous?
It's very prominent. It's named after an astronomer a Danish fellow called Tycho Brahe.
Oh.
And he was responsible for doing some very, very, very accurate measurements of the planets and how they orbited around, he thought, the Earth. And his observations, which he tried to make fit an Earth in the middle with the sun and the planets orbiting around
Yeah.
and the stars way out,
Yeah.
and he kept trying to make it fit and he couldn't.
Yep.
Even though he was convinced that that was how they were, and he kept trying different ways until a fellow called Kepler came along,
Yeah.
and he realised through his mathematical genius, really, no, if you put the sun in the centre and then you calculate and predict where the planets are going to be, it fits perfectly.
Wow.
So that was a confirmation that even though Tycho, the guy that got all these measurements together, before telescopes too, so it was very difficult, his data would not fit the Earth in the centre.
Wow.
Kepler, who was his offsider, who was his apprentice almost, came along and said, well, you know what? If you put the sun in the centre and the Earth orbiting around it, guess what? Every observation you have fits perfectly.
Yeah. Wow.
Some people never believed Kepler,
Yeah.
but eventually it became obvious and it couldn't be denied.
Wow.
So Tycho crater is a very bright crater, and it's bright because it's a recent crater, maybe a billion years old,
Yeah.
and as it hit the moon's surface, it threw out a lot of waste,
That's
a lot of dust and rock. And you can see those lines of dust and rock, and they're called rays, very bright white lines that stretch from the crater almost around to the other side of the moon,
Wow.
where they've been thrown up and just fallen down in a big line.
Yeah.
So that's why this crater is so bright. It's recent,
Yeah.
and the rays that it's left
Yeah.
are very bright. And so you can see it with the naked eye as a bright white patch on the moon.
Yeah.
Yeah, it's one of the few craters that you can at least know that it's a crater.
Yeah.
Because it's so bright.
That's right. That is fantastic, Roger. Thank you very much for that very clear explanation. That helps a lot. And then the other stuff that I wanted to get your opinion is, especially for our audience, if someone is trying to get into the astronomy, especially not probably some fancy expensive telescope and stuff.
Yes.
To begin with, what sort of binocular do you recommend just to start with?
Yep, it's not an expensive hobby to get into.
Yeah, yeah.
$100 will get you a very nice pair of binoculars.
Yeah.
Now, binoculars can range from very small to very large.
Yeah, sure.
Generally, anything that has a front diameter, so the front of your binoculars is between 40 and 50 millimeters, is perfect.
Right.
And you can get those online for $100, good quality.
Yeah, sure.
You can pay thousands for binoculars of the same size. And yes, they are better.
Yeah.
But to get you started, that's fine. Now, the important thing to remember is that no matter how good small binoculars are, they're never going to be as good as big binoculars.
That's right.
Because the laws of optics say the larger the lens, the more light you're going to see. No matter how good they are, they all have a limit. So yes, large binoculars will get you in to see more fainter things and more light, but they're more expensive and they're heavier.
Yeah.
So a good pair of binoculars, maybe even 35 millimeters to 50 millimeters.
Okay.
If you get on Amazon, you'll see what I'm talking about.
Yeah, sure.
They're fine.
Yeah, okay.
And that will get you started. You'll see a lot of clusters. You'll see craters on the moon.
Yeah.
You'll see the gas and dust in the Milky Way.
Yeah.
And you'll see the beautiful details of stars and their true colours as well.
Yeah. Thank you very much, Richard. Thanks for that amazing explanation. We'll look at Richard's work, especially the pictures of moon he has taken.
Yes, happy to show you.
Yeah, and so we'll jump into the computer now, and then what we'll do, we'll just look at this software where we can see all the constellations or any celestial bodies right from where you are, and look at some Richard's work. So we'll jump into the computer, and we'll show you some cool stuff.